derivatives. So I'm going to draw a function, okay, graph of a function. So here we go. Here's a function f. Okay, any function. And I'm going to take a random point here on my function, okay, on the graph. So let's say I'm going to take a point okay, so let's say A, and this is f of A. Okay. And what I want to do is I'm going to draw at that point, at point A f of A, I'm going to draw a tangent line. Okay, you know what a tangent is? Okay, tangent just touches the line, the curve touches the curve at one point. Okay, so this is a tangent line. At point A f of A. Okay, so nothing too crazy for now. I have a function. I took a point on my function, which is the point A f of A. And at that point, I draw a tangent line. Okay, now I'm interested, very interested, in finding the derivative of this, the slope of this line. Okay, the slope of this line here is what we call the derivative of the function at that point. Okay, so I'm going to write it down. So we are interested in the slope of the line that is tangent to the graph of f. Okay, so I'm interested in this slope. It's very important. You'll see that if you understand how to find the slope, there's a lot of applications. Okay, you've probably seen this in physics last year when you were in high school, when you had the position time graph. The slope of the tangent was what you call the instantaneous velocity. I don't know if you remember this. Okay, so it's a rate of change. So that's the whole purpose of what we're going to do next weeks, is understanding the rate of change. Okay, so every variation is interesting to you. Okay, so V. I'm going to give you another notation. V. Slope of the tangent to the graph of f at point A f of A is called the derivative, that's what it's called, of f at x equals a. Okay, and we write f prime of a. Okay, so this is the symbol. Okay, or could also write it this way: df dx of a. Okay, we're going to talk about this notation soon. Okay, this is the Leibniz notation. Okay, there was two mathematicians who invented really differential calculus. They're Newton and Leibniz. Okay, this was the Newton notation. This is the Leibniz notation. Okay, and you'll see that both have good application. What's important for now, we'll talk about this later. What's important for now is that we're interested in finding the slope to the graph, the slope of the tangent to the graph. Good, and that slope is called the derivative. I'll write it here. Slope is equal to what we call f prime of a. Any questions on the basic definition? Okay. So I need to be able to find a way to evaluate this slope, no matter what the function is. Okay. So first of all, the first thing I want to tell you is that I found the slope at A. I could find the slope at another point, another value B, C. Wherever I place myself here, let's say I was here, then of course the slope would be something different. It would be like this. So every point, right, has a different slope, right? As you see, slope, 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 different slopes, right? You see? So the derivative itself also depends on x. Okay, so I'll write this down for you. The derivative depends on x as well. Okay, so okay, leave it as this for now. Let me draw another graph, another function. And on this graph, now we're going to work a lot. Okay, so here's a function. I don't care how it looks like. And I'm interested in, let's say, the slope, I would say here. Okay. At this point here. Okay, so now I'm going to call this any random point, so I'm going to call it x. And this here, of course, will be f of x. Any questions? this slope here will be what we call f prime of x. Okay. So I need a way to find an expression for this. Okay. So we don't know much at this point. The only thing we know is we could rely on, we're talking about a slope. So I remember what the formula for a slope is, right? You remember how to find the slope of a line? Can you tell me?
AX plus B.
No, the slope, well, the A is the slope. But let's say you have a line, you have 2 points, how do you find the slope?
y2 minus y1 over x2 minus x1.
Very good. Okay, so it's delta y over delta x. So the variation of y divided by the variation of x. So if, in other words, the slope, what it means is if I move to the right by 1, by how much do I increase or do I decrease, basically? Okay, what's my raise over my step? Well, I step 1, how much do I go up or down? If every time I go 1, I advance 1 and move up by 2, my slope is 2. If every time I move up, I'm advanced by 1, I go down by 10, my slope is minus 10. That's what it is. That's all it is. Okay. So that's the only thing I know, and I know limits, and that's about it. Okay. So what I'm going to do is I'm going to take another point. Okay. Are you following me so far? Okay. I guess your silence means I guess you understand. So what I'm going to do is I'm going to take another value a bit further here. Okay, a little bit further, and create, but not create, I mean locate another point on my graph. So right here, let's say, okay. So this point here, so this will be, let's say, I'm going a certain distance here, let's say h. I'm going to call this distance h, okay. So this distance is h, and this is x, so this will be x plus h, right? Right? H further. Okay, and so what is this here? So this is x plus h. This is what?
F of x plus h.
Very good. So f of x plus h. Are we good so far?
Yeah.
Okay, no questions. All right, so I'm going to do the following thing. I'm going to identify the 2 points that I have. I have 1 point here, 1 point here. So the point here on the bottom is point x, f of x. And the point here on top is x plus h and f of x plus h. Good? And I'm going to connect these 2 lines, these 2 points, sorry, and create this segment here. Okay. And what I'm going to do now is I'm going to find the slope of this red line. Okay. So what is the slope here? So I'm going to write it right here. So the slope what is the slope here? Can you tell me the slope of this red line?
F of x plus h minus f of x over x plus h minus x.
Very good. So it's f of x plus h, which is y2, minus f of x, which is y1, over x2 minus x1, which is x plus h minus x, which is just h. Is this okay?
Sorry, how did you get h?
H is x plus h minus x.
Okay.
Okay. Okay, who doesn't understand, who doesn't agree with my red formula here? It's very important before I move on. If you have hesitation, any hesitation here, let me know, I'll repeat.
Sir, can you repeat, please?
Of course. Okay, so again, I am looking, everything I'm doing, all this work, everything, I'm talking too much for nothing. What I want is the following thing. I want to be able to find the slope of this green line. That's what I want. That's my whole purpose here. Okay, so I have no way to find how slanted this line here. I don't know. I don't know. It's lying on the curve. I don't know how slanted it is. But what I do know is that I'm going to connect 2 points on my curve, connect them with this red line, and find the slope of this red line. That's the first thing I'm going to do. Okay? And how do I find this slope of this red line? Well, I have 2 points, x, f of x, this point here. And then I have another point here, x plus h, f of x plus h, right here, which is right here. And then I could find the line connecting these two, I could find the slope of this. y2 minus y1, so y2 minus y1, okay, divided by x2 minus x1, so x plus h, which is x2, minus x1, which is x plus h minus x is h. And so this formula here gives me the slope of the red line. Should I repeat again? Anyone? Okay, I guess it's okay. Okay, so very good. I did a lot of fancy work, but for nothing. Because I found the slope of the red line, but I want the slope of the green line. Okay, so it's not bad. I mean, it's better like this than like this, or any guess that I could have taken. But we're still off, right? The red line you see is here, while the green line, right? The green line is here. Okay, so green is here, and red is here. Okay, so they're off. But the thing is, I took another point, x plus h, way too far here. I shouldn't have taken that far. I should have taken it a bit closer. I should have taken it here. If I would have taken x plus h here, it would have been better, because look what would happen. What would have happened? See, the red line would have been here. Do you see? You see what I just did? It's very important what I just did. Okay, so the fact that I took h a bit smaller, okay, h is this distance. So the fact that I took my second point a bit closer to the x makes this line here, the slope being a bit closer than the green. You understand? So the closer the h is to 0, in other words, the closer x plus h is to x, you see that the closer the slope gets to the green line. Do you understand? If I don't hear any yes, I'm assuming that, I mean, if I don't hear any no, I'm assuming that you understand. Okay? So if you really don't understand, you have to tell me. Okay? Okay, so in other words, f prime of x, okay, which is what I'm looking for, the green, is approximately equal, not exactly equal, to the slope of the red line, which is f of x plus h minus f of x divided by h. Okay. Approximately equal. We're still off, right? But we notice that the smaller the h, the closer the red slope is equal to the green slope. So what am I going to do to make it exactly equal? What do you suggest? If I don't want an approximation here anymore, I want exactly. What do I do?
Can we take the point that is exactly beside x and f of x?
Very good, very good. You're close. Okay, so I'm going to take the point that is very, very right next to x. So what you're saying?
Yeah,
Yes?
exactly.
Yeah, but how, you know that between any 2 points, there's infinitely many points. You know that, right?
Yeah.
So no matter how close you get, I could still get closer. So you're still off. You understand? So this becomes a very touchy question. Okay, it becomes a question that you're gonna deal with in calculus 2. Okay, towards the end of the class of the course. Okay, so but it's a very good reflex that you have. You're right. Let's make h very, very. Let's take 2 points very, very close to here. You're right. But how do we write this in calculus? Now we've seen a bit. How would you make this exactly equal, sorry, over h? How would you make this exactly equal to the derivative? How do you express what you just said? You said something very good, very, very close to x. How do you express that?
With limits?
Yeah, limit of what? Very good. So you're going to take the limit as what? Approaches what? I want you guys to say it. I don't want to say it.
As h approaches x.
Okay, as h approaches what?
X.
Well, if h approaches x, that means that I'm going from x to 2x. Because if h is x, then this becomes 2x. Right? So h approaches what?
0.
Yeah, 0. Okay, h, you were also close. H is the exact distance between these 2 points. Okay, this here, this distance is h. Okay, so I want this distance to be 0, as close as 0 as I can, right? So h approaches 0. That's what I want. Okay, this here is what we call the limit definition of the derivative. Okay, I'll write this down. This is the limit definition of the derivative. Any questions? Okay, that's all. That's all I have to say. Okay, nothing else. Once you understand what I just wrote here, we're halfway there. Okay, the rest is just now doing examples of applying this limit. Okay, could I go with the examples?
Yes.
Yeah, anybody want me to repeat, re-explain, leave it a bit for you to copy? Okay. So let's go. Let's do a few examples.
I would like to copy the formula. Is that okay?
Excuse me?
I would like to copy the formula.
Okay, copy it. That's what I just asked. Go for it.
Okay, I'm done. Thanks.
Okay, good. So let's go. So let's do now a few examples. Okay, we're going to do quite a few until you're comfortable with how to apply this. So example, let f of x equals to, let's say, 3x minus 7. Okay, so this is a straight line. We know that. Okay. Find f prime of x. Okay, so find the derivative of this function. Okay, so what do you expect it to be? Can you tell me? Could you know what the answer should be? before I start going into the calculations.
It should just be the same as the function.
What does that mean?
Because
The,
it's a
the
straight
answer should be a
line.
number. What?
I guess. I don't know.
Okay, so let me see. Let's see, let's try to draw this function, not exactly, okay, but at least the general sketch, okay? Okay, so you have to be aware or like you have to, as soon as you see a function like this, you have, in your head, you have to know what it looks like. Not exactly, but more or less what it looks like, okay? So what is this, first of all? Is it a curve? Is it a circle? Is it what? Is it a parabola? What is it?
It's
A line.
straight line.
It's a line, right? Y equals AX plus B, okay? And A is, of course, A is 3. And A, we know that it's the slope, right? And B is the y-intercept, right? You know this, right? This, you've been doing this since grade 9 or something, I don't know. Okay, so my function must have a slope of 3 and a y-intercept of -7. That's what it has, -7 here, and the slope is 3. We're good? Okay, so what is the derivative? What does it mean? The derivative gives me the slope of the tangent line. Okay, but this is a line, so the tangent at every point, it's just the line itself. Okay, it's not a curve where it just barely touches it. If I want to be barely touch the line, well, I'm touching the whole line, basically. Okay, you with me? So I'm expecting the slope, the derivative, to always be 3, because this is a constant slope of 3. The slope does not change. I'm not going too fast for anyone. Okay, so let's use the formula now. Let's do it algebraically. Okay, so I'm going to write here. So you should always do this at first, what I'm going to do now. So first, what is f of x? Well, f of x is 3x minus 7 in this case. Then I'm going to need f of x plus h. What is f of x plus h? Can you tell me? Anyone?
0.
0? How'd you get 0?
Because it's like there's no distance, like there's no h.
1 second. F of x is 3x minus 7, okay? So f is sort of a black box that packages my x. What does the f, what does this function, how does it function on x? It takes the x, it multiplies it by 3, and then takes away 7 from it. That's what it does, okay? It's like a packaging company, okay? You feed him an x, takes the x, times it by 3, takes the answer, minuses 7 from it, okay? So if instead of feeding him that machine, or that function, instead of feeding it an x, I feed it an x plus h, what is it going to spit out?
(3x minus 7 plus h).
Nope. Nope. It takes the x plus h. So instead of taking the x, multiplying by 3, minusing 7, now it takes the x plus h, multiplies it by 3, and then minuses 7. The exact thing that it does to the x here, it will do to the x plus h here. It's a function. It functions. It works. Okay? It's an employee. It's a machine. It's like a black box. You feed, spits. Feed, spits. You get it? Okay, I see on the chat that, okay, you got it. Good. Any question why this is like that? Would like me to repeat why f of x plus h is 3 times x plus h minus 7? Anybody? Okay. So now I'm going to use my formula for f prime. So I know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, and all this divided by h. Okay, good. And so now I'm going to replace limit h approaches 0. So f of x plus h is this guy. So 3 times x plus h minus 7. So this is f of x plus h minus, don't forget the brackets, f of x plus h minus f of x, which is 3x minus 7. And then all this divided by h. Any question? Okay. So now I have a regular limit that we've done much harder than this. Okay, that's not a complicated limit. So equals to limit h approaches 0. So let's open up the top. 3x plus 3h minus 7 minus 3x plus 7. And on the bottom I have h. Okay, and now it's time to clean up things. 3x minus 3x is out, minus 7 plus 7 is out. And so things simplify very nicely. Limit h approaches 0, so I have now 3h over h, cross out the h's, and so the answer is 3, just as expected. Okay, I was expecting the slope to be 3. So this is sort of a little confirmation that my formula, I'm not that off. It seems right. Are there any questions before I continue? I give you another example. Okay. Can I move on?
Yes.
Okay, so I always want you guys to do this. F of x plus h, f prime. Okay, f of x, it's important to go through this step of f of x plus h equals, because that's where most of you guys are gonna make mistakes. Okay, like you're gonna do 3x minus 7 plus h, you're gonna add the h at the end or things like that. Okay, so remember, every time you see an x here, you replace it by an x plus h. If it was 3x5 minus 7x plus whatever, you replace the x by x plus h, power 5 minus 7 times x plus h. Every x becomes an x plus h. Okay, let's try another one. So let f of x, so let's do x2. Find f prime of x. Okay, so now it's a different story. Okay, so now as you see, we're going to have a parabola. Okay, so there's a parabola. And so as you see now, depending on the x, right, the tangent will be different. Okay, tangent will have a different slope. Okay. So let's do this one, and then I'm going to give you a few to do on your own. Okay, so first thing I'm going to do is identify f of x. So obviously it's x2, and then f of x plus h. What's f of x plus h? Let me see if you understood.
X plus h squared.
Very good. So x plus h. The square is on the h or on everything?
It's on everything.
Very good. Okay. So basically, I just took here, and instead of writing x, I put an x plus h. So what did I do to the x? I powered it 2. Well, I'm going to do the same thing to the x plus h. That's what it means. Okay. Okay, and now f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h, which is equal to the limit h approaches 0. So f of x plus h is this guy, x plus h power 2 minus f of x, which is x2, and on the bottom I have h. Any questions? Equals limit h approaches 0 over h, and so on top I have x2 plus h2 minus x2. Right, we're good? You guys okay with this or no?
Isn't there also, when you're squaring the x plus h, isn't there, when you're squaring the x plus h, like you're opening it up, isn't there also a plus 2xh that should be written there?
Okay, very good. Okay, so I did it on purpose. I wrote it on pencil, okay? Because this is the mistake I always see, okay? You see the x plus h squared, you just go x2 plus h2 because you're in a hurry, and then you forget that x plus h squared is x plus h times x plus h, okay? So that's not good, okay? Exactly. Okay, I'll take back my black pen. So this is x2 plus 2xh plus x2 plus h2, and then minus x2. Now that's better. Okay, so I hope you spotted the mistake. So Gian, okay, you were writing the answer already. Yeah, the answer is right. What you're writing is good. So I'm going to cross out the x2 minus x2 is out. And then I'm going to evaluate the limit. H approaches 0. So on top, I could extract an h. H times 2x plus h. And on the bottom, I have h. The h's are out. And if you plug in h is 0 here, you're left with just 2x. So the derivative of x2, we just show that it's 2x. Good. Okay, so I have a few of you in the chat that are writing that you found the answer. Very good. Okay, let's understand what this means. Okay, so let's see. So at 1, at x equals 1, my slope looks like this. At x equals 2, my slope is a bit steeper, like this. At x equals -1, it's like this. And at x equals -2, it's even steeper like this. And at x equals 0, it's flat like this. Do you understand? I don't know if it's really clear. I should have drawn it bigger. But basically, if I want to see the slope here at x equals 2, well, I just have to multiply x by 2. So 2 times 2 is 4, so the slope here is 4. At x equals 1, well, 2 times 1 is 2, so the slope here is 2. You understand? At x equals -1, well, the slope here now is 2 times -1, so -2. Makes sense, it's a negative slope. At x equals -2, 2 times -2 is -4. And of course, at x equals 0, well, at the 0, you see that it's flat, so it would be, the slope would be 0. Does this make sense? Okay, so of course, if you want to go a bit further here, let's say x equals 50, okay, and you go to the point 50 and 2500, and you want to find the slope of the tangent there, well, it will be 2 times 50, it will be 100. You're going to have a slope of 100 over there. That's what it means. Is this clear? Okay, let me give you a few to try. Okay, so there are the classic ones. First, I'm going to give you one that's similar to this one, and then I'll complicate things a bit. Okay, so now let's do some examples. Find f prime of x. So first one, let's say f of x is equal to 3x2 minus x plus 1. Okay, start with this one. It's not too difficult. Try it out. First thing we do is we identify f of x. It's already given to us. 3x2 minus x plus 1, then f of x plus h will be what? This is where we have to be careful. 3 times x plus h squared minus x plus h plus 1. You understand this step? Okay, so every x becomes an x plus h. Question? So let's do now f prime is limit as h approaches 0 of, so we're going to be big one. So f of x plus h, which is 3 times x plus h squared minus x plus h plus 1. This is f of x plus h minus f of x, which is 3x2 minus x plus 1. And then all this over h. Okay. Equals, and now I'm going to open everything up. So limit as h approaches 0. So on top I have, so x2 plus 2x plus x2 plus 2xh plus h2, all this times 3. So I will get 3x2 plus 6xh plus 3h2 minus x minus h. Don't forget to change the sign here because there's a minus in front of bracket. Okay, so when I take out the bracket, I distribute the minus, plus 1, and then same thing here, minus 3x2 plus x minus 1. Okay, so don't forget to change the signs. All this over h. Okay, let's see what we can do here. So 3x2 minus 3x2 is out, minus x plus x is out, plus 1 minus 1 is out. Equals limit h approaches 0. So on top I can extract an h times 6x plus 3h minus 1 divided by h. The h's are out. And then plug in the h is 0 to what's left. So this term disappears. I'm left with 6x minus 1. And that's my answer. And that's what the answer that's the answer that you guys have, about half of you guys got.